Hey everyone, let's discuss Leetcode problem 2 sum. We are given with nums array and a target number. Basically, target number is addition of any two numbers in this array. 7 plus 2 is 9 and none other numbers add up to 9 here. So we have to return index of 2 and index of 7. That is 0 and 1. That's the output. For target 6, 2 plus 4, so index 1 and 2. And for target 6, we need to return 3 and 3, which is 0 and 1. Let's look at this example here. The target is 7. So if you take a look, 4 plus 3 makes up 7 and none other numbers in this array make up 7. By considering two pointers, one is the outer pointer and one is the inner pointer. Let's take a look how that works. Let me take I pointer here and a j pointer. I pointer is the outer loop. So as I move slowly, j moves very quickly. So what I mean by that is I is pointing to index 0 and j is pointing to index 1 initially. J always points to the index next to I. So in this case, I is pointing to 0th index and j is pointing to first index. We will add up these two numbers wherever they both are pointing. If that doesn't add up, we will move j. So initially we were here, so 6 plus 4, that did not add up because 6 plus 4 is 10. Our target is 7, so that did not match. Let's move this. Now 6 plus 5, that's still not matching with the target, so let's move this again. 6 plus 11, that did not match. Let's move this. 6 plus 3, we did not find the target here as well. So if you notice here, we keep I at 0th position and traverse j towards the end. If we don't find it, then the next step is to move the I pointer and we will bring back j right next to I. So the question a lot of people have is, why don't we start here with the j? So why don't we, when we move I, why don't we keep the j here? And the reason for that is, we already covered 6 and 4. Remember, it was first like this when we started. And 6 plus 4, we already covered. So that's the reason we don't have to cover this again, because this combination again leads to 6 and 4. So what we haven't covered yet is 4 and 5. So this combination, I being at first and j being at second index. So let's look at this now. So 4 plus 5, it's not still matching the target. Let's move this. 4 plus 11, that's not equal to target. Now it's equal to target. So 4 and 3. So 4 plus 3 gives us 7. So what do we return? We return the index of 4 and index of 3. So we return 1, 4. So this is the answer in this case. Things to remember in brute force is, we will always have two pointers. One is the outer pointer and one is the inner pointer. The outer pointer is I in this case because I moves very slowly, and while I moves 1, the j would move every element until the end of the array. If it didn't find, we will move I. That's why I said I is moving slowly and j will move to each and every element. The time complexity is generally n square. So this is the time complexity of brute force. It's O of n square because if you notice, for every I, meaning I being at every index, j will move towards the end. So we will reach multiple times to the end with j. So how many times we reach generally? We reach, in the worst case scenario, we reach n times. So how many ever elements are there, we reach those many times with j. And how many elements we traverse? We traverse n. So this is number of times we reach number of elements. So that is n square, and this is not optimal. Let's first code this and then look at how we can optimize this further. Let me make up some space here. Okay, let's first see how we can write the code for this. So like we discussed, I should be in the outer loop I'll take a for loop I is equal to 0, meaning I is starting from index 0, and how many times I should be iterated. So we need I at 0th index, 1, 2, 3, and 4. So we have 5 elements, 1, 2, 3, 4, and 5. So 5 times. So what do we take here? I less than 5. When I say I less than 5, we have I is equal to 0, 1, 2, 3, and 4. So the length of array is 5. So if we take less than 5, it reaches until 4. So instead of 5, let's generalize this and take it as n, because we have, or we can consider as nums.length in this case. I'm just writing the short forms here, and I++. So for each, after each and every iteration, I should increment by 1. So I'm taking I++. So hope this is clear. Now we have access to ith index. So now inside this for loop, when I say nums of I, that means nums of 0 for the first iteration, nums of 1 for second iteration, and so on and so forth. So we also need j because we are adding I plus j. So index of I plus index of j. So let's write another for loop here. So what must be the value for j? J must be starting from 1 because j must always start from the index next to I. So we can take I plus 1th index. So when I is starting at first index, j should be 2 and so on. So we will take until nums.length similar to what we took I because j is reaching until the end to the 4th element and j++. Now what do? We have access to nums of I and we have access to nums of j. So like we saw, let's add this and see if these two are equal to target. So we are checking, so I'll add a if statement here. So if nums of I is equal to nums of j, if nums of I plus nums of j is equal to target, if yes, then we will return I comma j, meaning we return the indices of those numbers. So if we don't find at the end, we will just return something. We can just return -1 and -1. And when we reach this case, it means that we did not find the number. So let's go to Leetcode and code this. So let's write the code for this. Let I is equal to 0. I less than nums dot length I plus plus. Let's write the inner loop. For j is equal to 0. Sorry, j is equal to I plus 1 because it has to start at the index next to I and it has to reach the end. So we will write j less than nums dot length j plus plus. So at this point we have access to both I and j, array of nums of I and j. So we will check if nums of I plus nums of j equal to target. If yes, we will return the indices of I and j. So what if we don't find the combination? Meaning, so what if we don't find the combination of I and j, which adds up to the target? We never hit this return statement. So we will reach end of the for loop. So at that time, we can just return -1, -1. Let's run this and see. Okay, so the answer is accepted. So let's submit. It shows success. But the second thing to notice here is it's faster than only 13.88 because this is not so optimal. Let's now look at the optimal solution, how we can do this better. Okay. Now let's look at the approach to how we can solve this. This is more optimized solution. So the idea is we have only one pointer here, which is I, and the idea is we use some kind of storage here. Let's say we use an object called memo, and as we iterate through I, we keep storing something inside this memo. So what is that something? We have target 7, and 7 minus 6 is 1. So let's say, for example, if we have this 1 here, which is already stored at, let's say, some index. So this is index 5. This is just an example. This is the actual value. And what we are actually doing here is 7 minus 1 is 6. So as we find this element, we check 7 minus 6 is 7 minus 6 inside this memo. And we found that's here. And what's the index of that? The index of that is 5. So what do we return in this case? 0, 5. Because index of 0 and 5 add up to 7. So that's the idea. And the tip is most of the problems which we use array, if it needs O of n, meaning if it has to be optimized, we use this kind of storage. So you can take this step and solve most of the problems in O of n. So let's take a close look how we can solve this. So let me write algorithm for this. We check is target minus value in memo as key. So we are checking if the target minus the value which I is pointing to, 6 in this case to begin with, if that is in the memo. So we don't have that in the memo. So we either will have it or we don't. So we don't know or we have it. In this case, we don't. So if we don't have it, we add this as index. So let me add this value as index. So this is the val, and I'll add the corresponding index, which is 0. So what did I do? I'll add val as a key and index as the value. Now let's move this I pointer to the next one. Now again we check is target minus value, which is 7 minus 4, is that in the memo? No. So we hit this case. So we will add value as key, which is 4 here, and index as value. So 1, we add 1 here. Let's continue further. We check if target minus value 7 minus 5, does it exist in memo? No, we don't. So we just follow this rule. Add 5 as value and its index, which is 2. Let's continue further. Now with 11, which is 4th index. Now we check is target minus value. So 7 minus 11. Is that in the memo? That's not in the memo. So we just write it. And the index is 3. So let's continue. Is target minus value inside the memo? If we add up 3 and 4, we get back 7. So what do we return in this case? The index of 3, which is 4, and the index of 4, which is 1. So we can either return 1, 4 or 4, 1. So that's why this approach is very effective, where we use this memo to register or record the values. So now we reach the yes case, meaning 7 minus 3, the target minus val in memo as the key. Yes, we have 4 here as the key. So what do? We return the index of I pointer. So what I is pointing to in this case 4, and we need to return this 4. So what is this 4? It's 7 minus 3, meaning we need to return this index. So this is the index, right? So we need to return memo of target minus value. So we return the memo of target minus value. So the target is 7 minus 3. So the memo of 4, we return memo of 4, which is the index 1. And we return this as array. So meaning in this case, we return 4, comma 1, or we can return 1, comma 4. So both are acceptable. And that's how we memorize this. Let's write the code for this. So let me take memo here. Memo means remembering something. So we are remembering the previous values, and for every iteration we are using that memo. Hence I've named this as the storage as memo. Let's initialize a pointer here for better understanding. Let me now write the for loop. Let me first compute the length of the for loop. So const length is equal to nums.length. And now I'll take this inside a for loop. For I is equal to 0, I less than length, I plus plus. And the reason I did this, I could have directly taken this here, but I prefer doing this way because this part computes only once and we don't have to compute each time inside the for loop. So it's very efficient in terms of processing. It will process only once because this nums.length never changes. That's the idea. I'll take the negative case, meaning if target minus, what's the value here? Value is nums of I. So nums of I, meaning nums of 0 in this case, which is 6. So I'm taking nums of I in memo. So I'm checking if target minus nums of I, which is value, which is 6 in this case, in memo, and that's not true. In short, I'm saying if target minus value not in the memo. So then what am I supposed to do? I should be adding 6 here and the corresponding index. So I should be adding memo of nums of I is equal to I. So inside memo, I'm adding nums of I. This is memo of 6 is equal to 0. So in this case, what happens? Let's trace this out quickly. So 6 got added. If we go to 4, we check if target minus nums of I. So target minus 4, 7 minus 4 is not in memo. It's not in memo. So we add memo of nums of I, which is memo of 4 is equal to index 1. So let's add that. Let's continue this. We do the same thing now. Target minus 5. So if target minus 5 in memo, 7 minus 5, which is 2, is it inside the memo? It's not. So if it's not in the memo, we add that. Let's move further. Is 7 minus 11 inside here, inside the memo? It's not. So we will add that as well. And finally, we reach the last element. And here we check is target minus value is target minus nums of I. So 7 minus 3. Is it in the memo? Is it not in the memo? But we have that right here. So this if loop doesn't hit. So we go here. So we need an else statement here. So let's write that. Else. Meaning if we reach else, we simply put, we have reached the end and we already found the element. So target 7 minus 3, which is 4, which is here. And this was the case which was not here, but in the else part, we already found the element. In that case, we return the array of I pointer and memo of target minus val. So we simply return the index, which is I in this case, which is 4, and we return memo of 4. So what is memo of 4? Memo of 7 minus 3, that is memo of target minus nums of I, and we close the for loop. In case if we don't find anything, meaning we have completed all the elements, we simply return -1 and -1, saying we did not find any element. Let's solve this on Leetcode now. Okay, so now we are on the Leetcode. Let's first define memo, which is our storage, and I'll assign that to an object. And we'll also define the length, which is nums.length. We will define a for loop, let I is equal to 0, I less than length. We will go through 0 through length, and we'll increment that every time. Now we will have two conditions. One is if we don't find the element, we don't find the element, then add it to memo. So if not, we need to negate. If we don't find the element, we need to write if target nums of I, target minus nums of I in memo, and if that is not true, then we add nums of I to memo as the key, and we assign that to the index. So basically inside the memo, we add nums of I, which is maybe the first element in this case. First element of the array, we are adding it to memo, and the value will be the index. What happens if we find the element down the line? We found the element in the else part. So we return the indices. So we return the array of I, comma, memo of. We need to return target minus nums of I, because nums of I is already stored, and when we do target minus nums of I, and if we find that in the memo, we return that along with the current index. When we come out of the for loop, we haven't found the combination but traced all the elements. We haven't found the combination but we traced all the elements. In that case, we just return -1 and -1. So let's run this and see. Yes, it works. So the output is 1 and 0, and the expected is 0 and 1. Like I said, it doesn't matter in this case. And the other point to notice here is I'm taking this negation within this bracket here. So if I make this way, if I just remove the outer brackets, it gives me the syntax error like this. So if we are starting an if loop with the negation, we always have to enclose this. So our answer is accepted. Let's try to submit and look at all the edge cases. So we submit the code, and you see it's faster than 89% of other JavaScript submissions, because this solution is optimized, and hence this is faster than most of the other submissions. So yeah, we have come to an end of the video. We have watched two kinds of solutions for this. One is the nested for loop method, and the other one is using a single for loop, which is O of n. So this is the optimized solution. Thanks for watching.